are today here at Jay Aerospace, a company that's redefining aerospace component manufacturing in India. Vishal and Venki, they spent decades building some of the most successful JVs for Tata Group with Boeing and Sikorsky.
Even today, more than 80% of manufacturing happens in high-cost countries, which is US and Western Europe. All of these countries are struggling with severe labor attrition and talent shortage.
And if you were to go and check any of these large OEMs, Boeing, Airbus, GE, you will realize that one of the biggest challenges that they face is in terms of supply chain constraints. And the need of the hour is today, how do you build resilience in your supply chain?
Shipping 100,000 components with no quality escalation is not an easy job. And especially in aerospace world where the tolerances are very tight.
Even today, 2-year-old company, we are end-to-end digital. It's a paperless factory. We see digital manufacturing as one of the most important differentiators can bring. We have theory training, where it's a classroom training, we have a practical training, and then we have an on-job training. So all aspects of manufacturing are covered.
Global supply chains are getting reorganized, and India, I think, is at a fantastic sort of position to take advantage of that.
We find a lot of inspiration of what Foxconn did in electronics. Now that's it's a big, hairy, audacious goal.
Hi everyone, welcome to the Day One podcast by Elevation Capital. As you would notice, the background for our podcast today is very different from what we've done earlier because we are at the entrance of a very special company. We are today here at Jay Aerospace, a company that's redefining aerospace component manufacturing in India. With me today is my colleague Ashay and Vishal and Venki, the founders of Jay Aerospace. Little bit on Vishal and Venki, they spent decades building some of the most successful JVs for Tata Group with Boeing and Sikorsky. And today with Jay Aerospace, they are building a global center of excellence that is delivering quality at scale. So welcome to Jay Aerospace. We'll walk in now.
Vishal, Venki, it's great to be here with you guys. Thank you for having us here. I want to tee things off with a very pertinent question. Something a lot of our viewers would actually have top of their mind while they're watching this, right? I think over the last couple of years, whenever we look up in the news, we keep reading a lot about aircraft deliveries being delayed to a lot of airlines, be it in India, be it outside, right? And you read a lot about saying maybe parts are delayed, aircraft deliveries are delayed, and so on. When we look deeper, the airline industry right now has a backlog of almost 15 to 16,000 aircrafts right now. I just want to tee things off by asking, where is the real bottleneck? And we'll chat more about this, but I want to start off with this question. Would love to get your thoughts.
No, so Ashay, I think you hit the nail on the head. Right now, if you see, the industry is in real difficult times, and especially the COVID and its aftermath has only accentuated the problem around demand and supply. As you rightly pointed out, this the highest backlog order that this industry has ever seen. Every year, the airlines are getting delayed in terms of getting their aircrafts. If you see today, and if you were to go and check any of these large OEMs, Boeing, Airbus, GE, you will realize that one of the biggest challenges that they face is in terms of supply chain constraints. And the need of the hour is today, how do you build resilience in your supply chain? Because different demand and supply shocks are going to come, and that's going to be part of life. So if you were to see and see the entire supply chain, at the top you have the OEMs, and then you have tier 1 and tier 2 manufacturers, and then below you have the raw material suppliers, hardware suppliers, etc. A lot of the value add happens at the tier 1 and tier 2 manufacturers, and that's where we have seen a bulk of the supply chain problems are there. And that is where Jay Aerospace is coming in, that how do you meaningfully build resilience in this supply chain to eventually help solve these bottlenecks, which can then help deliver the aircraft to the airliners.
Got it. No, Vishal, very, very interesting. And I want to just follow it up with a sort of a segue into the next point, which is a lot of these tier 1, tier 2, and a lot of this manufacturing right now still seems to be based in a lot of these high cost countries even now, right? Would love to get your thoughts on, is that the case? And we are also now seeing that early shift of that moving to, let's say, perhaps more cost efficient countries. So would love to get your thoughts on both, on whether this is happening and what's driving some of this shift.
No, I think very true. If you look at, unlike any other industry, aerospace industry, even today, more than 80% of manufacturing happens in high-cost countries, which is US and Western Europe, which is unlike any other industry, like you see automobile, white good, electronics, where a lot of manufacturing has already moved to low-cost destinations. That shift has not happened in the aerospace industry. Now, today, like you rightly mentioned, we are starting to see that shift happening in the aerospace industry as well. It's primarily driven by 2-3 factors. First, generally, like Vishal mentioned, during the pandemic, there is a huge decline in demand. A lot of shops got shut in US and Western Europe. When post COVID and the pandemic, travel has come back with vengeance. We have seen a V-shaped recovery in the demand, but the supply never caught up. That's actually because of a couple of reasons. The concentration is so much in the high cost countries. Today, all of these countries are struggling with severe labor attrition and talent shortage. They don't have people to work. So slowly we are looking at economies like India where there is an abundant talent pool that's available. Another thing that's playing out is generally whenever there is a manufacturing problem, in the past we have looked at China to be a go-to destination, right, for manufacturing. But in industry, with the geopolitical situation that we are looking at and sensitive industry like aerospace industry, China is no longer a preferred destination. That's where this opportunity opens up for a country like India.
Very interesting. Very interesting.
And Vishal, Venki, as you saw this opportunity emerge and you went about setting up Jay Aerospace, what were some of the learnings from your time at Tata, setting up all those JVs for 20 years that were like non-negotiables or design principles that this is how we'll build Jay Aerospace? Would love to just hear your thoughts on
I
that.
think Venki and I were fortunate, to play our small part in developing the aerospace industry in India. I mean, between us, we led the Tata Boeing joint venture, we led the Tata Sikorsky joint venture, we co-led the Tata Lockheed Martin joint venture. So one good thing that happened with us is that we learned from some of the best people in the world on how aerospace manufacturing works, what really good looks like for them. Now that has helped us to significantly shorten our learning curve. And all of those learnings, the good and the bad, we have brought in here. And now, of course, we are working towards, how do we 10x better what we have learned in the past. So let me take you to how we are doing it on our shop floor and you can look it with your own eyes.
Yeah. Folks, so we are in the center of resilience at Jay Aerospace. Venki, I had a question for you. This is our rapid prototyping hub. This is where we go from prototype to delivery in like 15 days versus the market taking weeks to do that. Can you walk us through this process of what actually happened and how do we pull something like this off?
Absolutely. Like you told, generally industry standard is anywhere between 15 to 16 weeks to industrialize a component, right? That we have been able to successfully crash from 15 weeks to 15 days. Obviously, there are very select initiatives that we run which makes this possible. Firstly, we stock all the standard aerospace grade raw materials which are required for manufacturing these new products. Generally, if you look at lead time, in the lead time of industrialization, raw material is a very big contributor of the lead time. Second thing, all of our machines in the new product development cell are run by engineers, which means changes on the go, edits on the program on the go, changes in the process on the go, which makes it extremely efficient and extremely quick. Second thing is, how do we do our programming strategy? We have actually created modules of our programs, which are for a particular feature. Next, anytime when we get a part, we actually put together all of those features, run through this program and quickly assemble all of that together, which crashes our programming time drastically. Fourth thing that we do is we commonize a lot of cutting tools, so that we can use these same cutting tools for developing any of the other components. Here, for us, what's important is speed. We are not here on efficiency. We are focused on effectiveness. That's what makes it possible to crash this down from 15 weeks to 15 days.
Very, very interesting design choices. Maybe I'll request us to just walk outside so that we give our viewers a wider view of where we are and then we'll continue our conversations. Awesome. Folks, so we are outside the Jay Aerospace Center of Resilience. I think you guys can get a great view from here. I want to continue our chat with both Vishal and Venki. The next question I wanted to sort of ask you guys is, we have talked a lot about software-defined manufacturing. It's a fairly unique term. I actually just wanted to double click and just ask, what does this really mean? Like, how do we think of this? And would just love to just go a little deep here.
So Ashray, if you actually see, aerospace manufacturing is an advanced manufacturing. But if you were to really zoom in, when it comes to digital adoption, the entire industry is quite laggard. It is quite not there up to the mark. Now, what we had thought right from the beginning is that we see digital manufacturing as one of the most important differentiators that we can bring. And digital should not be a strategy that you just put in later, but it is something that you integrate it with how you define end-to-end manufacturing. So I'm very happy to share with you that even today, as a 2-year-old company, we are end-to-end digital. It's a paperless factory. So right from the purchase order to the delivery of part, the product life cycle management, the core ERP, the manufacturing execution system, end-to-end is on a digital thread, and it defines each and every step we do in our manufacturing process.
Got it. That's actually really, really interesting to hear, because even now when we actually look through a lot of factories, as much as everyone says digital, it's very hard to live that 100%, right? So it's truly, truly refreshing to see this kind of a DNA and the call we have taken to sort of go like completely software defined and 100% digital. Really, really nice to see this.
Now maybe we can walk over to the Center for Skill Building that we have.
Let's right.
Folks, now we are at the next section of the J manufacturing facility, the Center for Aerospace Skill. This looks like an increasingly impressive facility for a company of our age. I want to understand, so when we look at the Western markets, the manufacturing workforce over there is aging very fast. But we need to almost manufacture talent here. How are you going about doing that?
So we go by this saying internally, talent cross technology come to transformation. What Venki demonstrated to you at the Center for Resilience was on the technology side. Over here, we are focusing on the tech. Now, as you rightly said, the labor workforce in US and Western Europe is aging quite quickly. A lot of people do not want to necessarily join the manufacturing industry. In India, we have a different kind of a challenge. We have the potential and availability of a large, talented workforce, but at the same time, not all of them necessarily understand what is needed to do aerospace manufacturing. So instead of outsourcing something so critical, a company of our age, we have still kind of insourced it and made a captive training center, a Center for Aerospace Skill. Also, if you'll observe that this over here goes in 3 stages. We have theory training, where it's a classroom training. We have a practical training, and then we have an on-job training. So all aspects of manufacturing are covered. So by the time a person starts from classroom till the walks out of the door, he is ready to do aerospace manufacturing. Another critical thing that we have done is that we have made a closed loop with our 8 production floor and our training center. So any challenges, any issues that we face in the production shop floor is quickly fed back to our training center. The syllabus are upgraded, and the same thing then gets solved right at the training level.
I can see a classroom and then the practical happening together. Yeah, that's fantastic. I think when we had come the last time around, there was like the first batch that was getting trained out. So, like in India, we've always said that we have great engineering talent, right? What does it take for that engineering talent to become aerospace ready talent?
So I think a couple of things, right? Like you rightly mentioned, we have more than 1.5 million engineers that graduate every year in the country, right? But all along we have seen there is a gap between what the academia is producing and what the industry wants. There is a clear gap from a manufacturing perspective and more so from aerospace perspective. There are a couple of things, right? Firstly, in aerospace, the quality requirements and the quality standards, precision are very, very high. So what we do as part of our training center, in-house training center, we teach them all the necessary aerospace standards. We train them on the AS9100 requirements and also few customer specific requirements so that they're up to speed in terms of what industry needs, what are the quality guidelines that are required. Second thing, in aerospace industry, while machining and manufacturing is important, measurement is equally important, because here we are talking about very close tolerances, right? The closest that we know is automotive, where we are talking about tenths of mm. Here we are talking about micron level tolerancing. So we also teach people about the metrology of the aerospace manufacturing, how to use the CMM, how to use very precise instruments, so that they also understand what good looks like and how do you measure and understand what is required in the aerospace industry. Third thing that also we imbibe right at the beginning is how critical and how important is safety in this particular industry, because at the end of the day, you're making something which is actually carrying humans in air. It can be, it is as critical as it can get, right? So we imbibe that safety consciousness and quality consciousness right here before we induct them into the shop floor.
Fabulous. No, this is fantastic. I love how you keep repeating. We tell everyone what good looks like. Yes. And that is what is taking the engineers to aerospace ready engineers. Fabulous. Maybe now we can walk over to the heart of the facility, our shop floor.
Yeah, place where we make money.
Yeah.
We are now on the main production shop floor. Venki, I had a question for you. Can you explain to us a journey of a component right from raw material all the way to shipping? Can you walk us through like what happens?
No, absolutely. I think it even starts before the raw material, Ashray. It all starts with you receiving the engineering data from your customer, right? Which includes your drawings, specifications, all the standards that are required. The first step starts with we studying all those necessary specifications, and then starts our process plan, where we actually define a sequence of steps in which we convert this actually 2D drawing into a 3D manufactured part. This also has multiple layers and steps. First, like I told, we start with the process design. Then we do a fixture design, where anytime you have to manufacture a part, you also need to know how do you hold this particular part in a machine, which is where the fixture comes in. Then we design the fixture. Then we also do something called as NC program. This is basically your way of communicating how does your spindle move in the machine for you to create that profile of that particular part. So you do your NC programming, and then you do your setup on the machine, where you use the fixture that you have made earlier and set it up on the machine, and you do the manufacturing process. It goes through the manufacturing process. Generally, manufacturing process happens in 2-3 stages we call as OP10, OP20, which is basically you creating different profiles that are called out in your drawing. Once this manufacturing happens, then we actually send the part back to inspection. And during the inspection process, that's when they check if the part is actually as per engineering or not. There we use some precise instruments like CMM, vernier calipers, your height gauges, etc. and measure all the features that are there on the part just to check if it is matching the blueprint or not. Once all of that is done, the quality team will confirm that this part is compliant to the drawing that's been provided, and then we pack and ship that to the customer. So those are the various steps at a very high level that are involved in manufacturing process.
Fascinating. Not like one would not think through on the level of steps and the attention to detail required to pull all of this off.
Yeah.
And I want to just dive deeper into one point you very briefly touched upon, which was around quality.
Yep.
Where you talked about like how we actually do a quality inspection process.
Yes.
So I want to actually just go deep on the fact that we have shipped almost 100,000 parts or more than 100,000 parts by now.
Yeah.
With zero defects.
That's right.
What's the secret sauce? Like we have talked a little bit about some of the steps, but would love to just peel the layers of the onion a little more and understand what are the systems behind this. What do we do in terms of culture, DNA to actually sort of pull something like this off?
Absolutely. Shipping 100,000 components with no quality escalations is not an easy job. And especially in aerospace world where the tolerances are very tight, the requirements are it's very, very difficult. However, actually the process of this happens much before actually part gets manufactured, Ashray. There are several steps that we follow. We have adopted the APQP methodology where we develop PFMEAs, control plans at the process planning stage itself. Like I have explained you during our part manufacturing process, there is a process planning stage wherein we actually do an entire APQP and build a PFMEA and control plans for this. What does this mean? So we identify every feature on the component and we identify what is a measurement instrument that we need to use to inspect that particular feature. And we also follow these SPC techniques wherein you actually, as you're manufacturing these parts, we identify what are the critical parameters and we also check the variability in these parameters. We define the process in such a manner, there is such a close control on this process, the variability is very minimal. Once we are able to get the SPC levels that are required, in fact, we need not even check all the components. Then we can move actually to samplings where you start inspecting 1 in 10, 1 in 50, 1 in 100. All of that is possible. But for this, you'll have to reach a very high level of process control and very high level of repeatability.
Got it. Oh, fascinating. I think it's very interesting to understand the backstory and the minute details that go behind actually making something that all of us experience fairly regularly in our life.
Yeah.
So I would say very, very fascinating to hear all of this. Maybe to continue the chat, I think maybe why don't we go ahead and sit out in the main factory area and continue our chat there.
Sure. Absolutely. After you.
Fantastic. Very nice place to sit. You can see the whole factory getting built around us.
So now let's flip the script. Let us now
I didn't know
ask
these
you a
were
few
the hot
questions.
seats. We should have been sitting there.
So let's ask you this question. So what made you and Elevation Capital invest in J Aerospace?
See, Vishal, Venki, I think the first sort of bullet point in any investment thesis for us is always founders. And couple of things that stood out for us as we spent time with you. We heard so many wonderful bottoms-up insights about what it takes to build the best aerospace manufacturing facility in India. That came from you based on your experience. Then we went out and spoke to other people in the industry. and they validated those insights. We spoke to people who worked with you, and the kind of words that they used about you, the praise that they had for working with you, it just convinced us that if we want to invest in this space, you are the people we want to work with. So for us, that was one big tick, that these are the people that we want to invest in. Maybe Ashay, you want to share?
Yeah, no, I think as we talked about, I think it's both of you, which of course are first and foremost. But beyond that, maybe a couple of other points. One was, of course, the market opportunity, which we talked about briefly in our chats through the facility, where I think global supply chains are getting reorganized, and India, I think, is at a fantastic sort of position to take advantage of that. So that, of course, is one very interesting fact. I think the second point, which excited us quite a bit, was our execution capability to go from idea to all of this over the last 18 months is truly, truly commendable. It is absolutely not an easy thing to pull off. I think the level of depth we see here, the small attention to detail, doing a lot of the hard stuff day in, day out, and being able to get to like millions of dollars of scale in this time period, I think that's a big factor. And lastly, I think we again touched upon this briefly, which was our digital first, software defined sort of approach on manufacturing, right? I think those are the things that allow us to set ourselves up very well for scale. So one, I think a combination of market plus the way we've been able to execute plus what then gets us from here to where we want to go. I think all of that basically over and above both of you, of course, I think got us super, super excited.
No, very, very grateful, for putting your confidence, and we're sure that we'll build on it.
No, we are super excited to partner with you guys. Now maybe regular traffic. One last question from our side. So we've talked about what made you start. We've spoken about what all you've built. Let's fast forward a few years down the road. From today to becoming a global aerospace manufacturing powerhouse. What does it take? What does that journey look like? What is the future for you guys?
So that's a good question, right? I mean, it pushes us to think forward. If you see, we have to do three important things. One, we have to significantly increase our capability and capacity if we want to make a meaningful dent in this space. So that is what we would be trying to do, is that how do we significantly expand our manufacturing capability and capacities. The second thing that we need to do is to build resilience in this global industry by having presence across locations, not just in one place in isolation. So that's the second thing that we'll have to do, that we don't become a one location organization or even a one country organization, but that we have places across. And third, we will have to do is that we will have to play across tiers. There are challenges across tiers which are peculiar in those areas. So it would be, when I say across tiers, it would be across the tiers of supply chain, across the tiers of product category, and across the tiers from manufacturing to design. So those are 3-4 areas when if we want to do. That's what a large scale would look like. We find a lot of inspiration of what Foxconn did in electronics. Now that's it's a big, hairy, audacious goal, and it's a very long-term thinking. But that inspiration is what really drives it. How can we create that J for aerospace industry?
Fabulous. Did you use the word audacious because we are built for the audacious?
Built for the audacious.
Fabulous.
No, awesome. I think this has been a fantastic chat. Maybe in closing, I just wanted to sort of leave with one thought for all of us. I think we are building a truly global supply chain solution out of India and addressing, I would say, what needs to be addressed here is a very basic but more elusive promise, which is the right part at the right quality at the right time. And as I pointed out, I think it's the most basic and elusive promise here. And we truly believe that's what Jay is doing. And we are very excited to partner with you and be with you on this journey. So onwards and upwards, very excited to see how this journey unfolds.
Likewise.
Thank you. Likewise. Yeah.
Grateful for your trust and leadership.
Fantastic. Thank you so much for having us here. It was truly a pleasure. We had, I think, a great time. Thank you.
Same here.
Same here.
Pleasure.